In this video tutorial, we're going to talk about how supports are created automatically in Adapt Builder 2019. This also applies to older versions of the software. And we're specifically going to talk about what happens when we have a column or a wall that is located above the reference plane but not connected to a slab. And so first we'll just talk about a few basics of auto restraint and also manual restraint in the program. To start, we're going to just create a slab. I'll just go ahead under model and create this slab region here. And we're going to add a couple of walls. We'll also add a column, a few columns there. And I'm going to go to a side view and then just copy these vertically. So I'll use modify, vertical copy up. We'll do something like that. Now, if we look at this model, we don't really see any supports at this point. So the program has some settings under the criteria analysis and design options to create automatic restraints. For single level analysis, the restraints are set to a roller support and rotationally fixed at the base, and they are rotationally fixed at the upper columns and walls. So if we go ahead and analyze this, I'll go ahead and mesh this. Let me go ahead and save the model also. Okay, and we're going to execute the analysis. So you'll note again, there's no support shown. So at the onset of the analysis, the program will actually create the supports that restrain the structure per the automatic settings, again under analysis and design options. And if we go to the view of those supports, if we go to model or even under visibility view settings, we can check to see what those supports are. So if I turn on the visibility for point and line supports, we can see at the base of the structure, this is going to be a fixed roller for any column or wall below the reference plane. So this is fixed vertically. If we go to the top above the reference plane, then we get this rotationally fixed only. There's no vertical restraint, otherwise this would become a hanger. And so these are the automatic supports. Now the user could always assign those, or let's say create them and then view them prior to the analysis. So if we go ahead and just delete out the mesh, I could also, for example, go to the visibility option again and maybe delete the supports. So I'll delete the line supports in this case. The point supports get deleted when I remove the mesh, but here I'll remove the line supports also. And before we actually analyze or even mesh the slab, I could go to model and I could create the supports automatically. I could create these. Those are again created based on the analysis and design options. And let's say I want to make a user modification. Maybe this needs to be fixed in the X and Y. This becomes a user modification. So until I actually go back and delete that, that is stored at that location regardless of whether or not I remove the mesh and reanalyze or reapply the creation of the supports. Now the situation arises where we might have a column or a wall outside of the slab boundary. Maybe it's a two-story or clear story column, and so we'll go ahead and add that here. And maybe it starts at this particular level and goes vertical. So we're going to create a couple of columns there. I'll create some walls out here. This happens fairly frequent in models in the program. Now these are currently modeled below the reference plane, which is the current plane. This is the plane that the analysis is taking place at. If I take these components, I'm just going to select those holding the control button down, and I'm going to copy them vertically. So we'll go to modify. I'm going to vertically copy or move them. It'd be easier to move them here. So I'll move these to the top plane. And now if we go to the visibility and just look at this, you can see those are now above the reference plane. So for any column or wall that is above the reference plane, the program is only going to auto restrain the top. Therefore the bottom has no support, and you get a stability warning. So if I come back and I remesh this structure and I go ahead and execute, I'm going to allow the program to create the automatic supports except for the line support that I created underneath this wall. And you can see there's a stability warning. When this happens, this means that there's excessive displacement or rotation at some frame or shell element in the structure. And I can now go to View Analysis Results, and to see this, if I look at the deformed shape, you can see the slab is all one color, meaning it's somewhere within this range of deflection. And that tells us that somewhere else we have some severe displacements to this magnitude. So I can now maybe turn on the warping, and you can see all of my walls are just free falling. They're displacing. If I turn on the line diagrams here for my components, let me turn off warping. The program shows then the line diagram. So here the real problem are the walls. And looking at the 3D view, you can see those walls are just kind of moving downward that are outside of the slab. So the solution to this is if we're really focused on just designing, let's say, or analyzing this slab, we don't really care what's happening on the outside. There's really a couple of solutions. One is to just disregard these components. So if I take these components, select them again, and I go to modify the components, modify selection, I'm going to disregard these components. The program just ignores them in the analysis. If I come back and execute again, the program is stabilized because it's not doing anything with those components. We look at the displacements. We can see this now has some normal level of deformation. There's no issue on those columns that are disregarded or those walls that are disregarded. Another option, let's go back and consider these. We'll go back to modify the selection, and we're going to modify back to consider for FEM. And now what the user can do is if you want to consider them, then we have to add the support at the bottom of these components that are above the reference plane but not connected or touching a slab. So I'll first go to model. I'm going to generate the automatic supports. Notice that it's only supporting these components at the top. They're rotationally fixed. So I'm going to add a support. I'll go ahead and add a line support. This is actually point support. We'll add those first. Let me turn on the snap option there. I'll add a point support there, and then I can manually go in and adjust the fixity. So we'll give this a vertical reaction only. Okay, and then we're going to add a line support. So I'll go to supports, line support. See if we can grab that location. Still have a point support there. Let me make sure I have the line. There's a line support. We'll go from point 1 over to point 2. So go to this view here, and I'm going to turn off the view of the supports. We can do that from visibility. Okay, we'll go to this option for line support. This is not to be confused with the automatic supports created at the top of the walls automatically. We'll go back to this 3D view. You can see the line supports now at the base, and these should be set to fixed. So we'll leave those alone. All of these line supports that I've created and the 2-point supports are manual supports. That means the program does not remove them automatically. They are only removed when the user selects them and deletes them. Or you can also select them and disregard them, similar to the walls. So this is a little bit more intensive of a solution or a workaround to making sure that this is stabilized. If we now go and execute the analysis for this model, we should get a stabilized model, and we can now go here and underneath the displaced shape we get something similar. You can see these walls are just not moving. If you have any questions about anything pertaining to the video, please contact us at support@adaptsoft.com.